In this next unit, we're going to start taking a look at three-dimensional objects, and we're going to be trying to find the volume of them. Volume is related to area. The area is two-dimensional, volume is three-dimensional. We use some of the same skills, some of the same formulas, just we got to take it to the next stage. And the first idea about volume is we have a bunch of different shapes. Today's idea, we're going to look at prisms. A prism is any 3D shape that has the same top and bottom. They're separated by rectangles. So the most obvious one is the box, right? We have a top one that's a rectangle, a bottom that's a rectangle, and the part in between is obviously a rectangle. But there are other types of triangular prisms also. Triangular prisms got triangles on the top and the bottom, and each side is made up of rectangles. Even this one over here, the cylinder, has circles on the top and the bottom, and if you unfold it, this part in the middle turns out to be a rectangle, just rolled around. Right? Think of like a paper towel. When you actually tear it off, it becomes a rectangle, even though it looked like it was round. These things on the right-hand side here are not prisms because it's got a bottom, but it's got no circle on the top. It's missing. Obviously, the ball has no top or bottom, and the pyramid, again, has a bottom, but it's missing the top. It doesn't have a shape that matches it on the opposite side. Okay. Whenever we do prisms, and in fact, whenever we do most of our shapes, we're going to use the same idea. The idea of a prism is if you can figure out the area of the base, let's start with a nice one here, a circle, okay, that would be the top and the bottom. All I have to do is figure out how many other circles are in between it. Okay, a bunch of them all stacked up on top of each other. That's really what makes a prism. So I've got one circle, the formula for that would just be the area, and then I stack them that high. So what I'm going to use here is B for my base, big B, times however tall they are. Okay, where B is just the area of the base, whatever shape the bottom happens to be. Those formulas are actually on our formula page we already have. They're on the back side, but really you don't have to memorize them because, well, we're just doing the same thing over and over again. The area of the base times the height. So let's take a look at the first shape here. The nice shape, the rectangular prism. I'm going to think of the bottom as that shape down there. That's a rectangle. The area of a rectangle is length times width. In this case, 10 times 15, which is 150. To find the volume, I'm going to take my base, big B, and times it by how many rectangles are stacked on top of each other. My base was 150, so the number right there, times how tall is this shape? Well, it's this many rectangles stacked up on top of each other. 6 of them, or 6 meters worth. Multiply that together and I get 900 meters cubed. And the reason it's cubed is we've now got 3 of the same things being multiplied together. A length and a width and a height. And all volume shapes are cubed. And let's take a look at the next shape. The tent, if you will, or the Toblerone bar. The triangular base prism. So when I think about the base isn't necessarily what's sitting on the bottom. It's the shape that's the same on the top and the bottom. Or in this case, the front and the back. The base of this shape is actually a triangle. There's a whole bunch of triangles stacked up on top of each other, okay, all the way to the back. So if I want to find the volume of this, I'm going to take my area of my base, which is a triangle, so base times height divided by 2. My base and my height have to meet at a right angle. There's my right angle, which makes this my base, and my height. 15 times 10 divided by 2 comes out to 75. And to find my volume, I take the area of my base, my big B, nothing, times how many of those are stacked up on top of each other. The big B was 75. I've got a whole bunch of triangles stacked behind each other in this case, 36 centimeters worth. I'm going to multiply those two numbers together, and I end up with 2,700 centimeters cubed. Again, the big idea is find the shape that's the same that's being stacked up on top of each other. Sometimes it's front and back, sometimes it's top and bottom. We'll try the third one. That's the only other prism we're going to deal with. So what kind of prism is this? It's a circular prism. A whole bunch of circles stacked up on top of each other over and over and over again, all the way to the top. also called a cylinder, right? How do I find the area of the bottom? Well, the bottom is a circle, so pi r squared. Do they give us the radius? Well, let's take a look at our diagram here. They give us a line that goes all the way across. Well, that's not a radius, that's a diameter. But if my diameter is 18, my radius goes halfway across. It's going to be 9. Always the half of the diameter. So we're definitely going to need a calculator for this one because we've got the pi button and the exponent button. If you type that in, you should get 254.47. How do I find my volume? Same thing. Big B times H. The base, that's that number, 254. Times how many circles are stacked up? Well, a whole bunch of them. 30 meters worth of circles. That's my height. And it comes out to, it's a big number this time, 7,634.1 meters cubed. Okay, so the same formula basically 3 times for volume, right? It's always this formula. The only difference is figuring out what the bottom of the shape is. In this case, it was a circle. And the only choices there are circles, squares, or triangles. Okay, let's try some problem-solving things, some word problems, if you will. How much sand is needed to fill a cylinder container that has a radius of 10 centimeters? So the trick in this case is they didn't draw us a picture, but we should be able to draw ourselves a picture. It says we are filling a cylinder. A cylinder is a circular-based prism. There it is. It tells us it has a radius of 10. Okay, so halfway across the bottom must be a 10. And it's 25 centimeters high. So 25 goes from the top to the bottom. How much sand is needed to fill it? Well, filling something is what volume's all about. Let's find the volume of this shape. We start with our base. Our base is a circle, pi r squared. Did they give us the radius? Well, yeah, they said 10 is the radius. Okay, so 314.15. Our volume takes our big base times it by the height. So it's 314.15, and they told us it was 25 centimeters tall. Multiply it all together, and you should get, oh, big number again, 7,853.75 centimeters cubed. Same question as the previous one, just no picture. Draw it out, see what we got. Okay, let's try another one. Alicia wants to pack CD cases into a storage box. What is the largest number of cases she can pack into the storage box? So here's our CD case, the small one. Here's the box. How do I figure out how many CDs fit in the box? Well, I could figure out the volume of them. If I know how much one CD case is and how much space I have, I can divide the big box into small little boxes. Let's give it a try. So let's do the CD case first. Area of the base. Well, that's a rectangle. The base is 14 by 12.5. We multiply those together, we get 175. So one CD is volume, big base times height, and the height is just 1 centimeter tall, is 175 centimeters cubed. I can do the exact same thing with this box. Find its area, length times width. In this case, 28 by 38 are my bottom measurements. And that comes out to 1,064. And then I can do my volume, 1,064 times 10. And I know that the whole box is 10,000 centimeters cubed. So how do I figure out the number of cases that fit? Well, I've got to figure out how many times this goes into this. How do I figure that out? Well, I've got to divide a big shape into small shapes. Key word there, divide. The number of cases will be 10,640 divided by 175. Big shapes into small shapes. So we always divide. Now when we do that, we get 60.8, which is an interesting number. I can't actually fit 61 cases in there. I'm not quite big enough. So this is the one case where we kind of have to round down. She can fit 60 cases. I can't squish that last one in there, not quite. So we have to round it down, even though normally in this situation we'd round it up. Okay, it's a good example of how I can use volume to problem solve. Let's try one more. Determine the volume of a square nut with the dimensions shown. The length and the width of the nut are both 20 millimeters. The radius of the hole is 7 millimeters, and the depth of the nut is 1.2 millimeters. So all the diagram is telling us is the information from the question. Show your work. So this kind of goes back to our last unit where we had composite shapes. The nut is really made up of two different shapes. The outside of the shape is a rectangular prism. Rectangular prism. That's like this thing outside, right? With 3 dimensions. But the inside shape happens to be a different one. What's the inside shape? Well, it looks like a circle, but because it's 3-dimensional, it's actually a cylinder. Right? That's what that is, which is a circular-based prism. Well, actually, it's called a cylinder. That's what it's really called. Cylinder. That's some really bad spelling. Okay, so how am I going to do this? Well, I've got to figure out the whole shape and then cut away the inside shape. In other words, I have to subtract them. So let's get to work on this. How do I start? Always the same. The area of my base. Well, the red shape, the outside shape, is a rectangle, which measures 20 by, here's a little trick for us, it's a square nut. So I didn't label it, but this is actually also 20. So I get 400. And my volume, base times height, which means 400 times, how tall is the nut? 1.2. So I got 480 millimeters cubed. The cylinder has a base, that's a circle. Pi times my radius. The radius it says is 7, said in the question and in the picture. So for this one I get 153.94. But I want volume. Big base times height. Same formula over and over again. Kind of my big idea today. And the height of this was the height of the nut already, so 1.2. Okay, and for that one I got 184.73 millimeters cubed. But remember, we're actually missing the space in the nut, right? The volume of the overall shape is the 480, and we're taking away, we're cutting out that middle piece. It's blank, it's empty. So what do we get for that? I got 295.27. Okay, the volume of the nut, that's a word problem. Volume of the nut is 295.27 millimeters cubed. So in this question, we've kind of combined a whole bunch of ideas. We have volumes and areas, but we also have composite shapes, where we've taken shapes away from other shapes. And that's kind of what we're going to do in this course. We're going to have to problem solve, not just know the basic shapes, but actually do something with them. All right, try this sheet on the website. Right, so finding some volumes. Some of them are just basic shapes. Some of them you have to think a little bit, draw a picture, problem solve. If you're stuck, just come see me and we'll figure some stuff out.